तो बच्चों इस वीडियो में हम लोग ये प्रॉब्लम सॉल्व करने वाले हैं। द रिकॉइल स्पीड ऑफ ए हाइड्रोजन आइटम आफ्टर इट एमिट्स द फोटोन इन गोइंग फ्रॉम n equal to 5 state to n is equal to 1 is, so we have to find the recoil speed of the hydrogen atom. So basically what happens is that when the hydrogen atom is going from the n is equal to 5, that is higher energy level, to the lower energy level, what happens is that photon is emitted. And when the photon is emitted, we can calculate the wavelength using this formula. Okay, 1 upon lambda is equal to r into the bracket 1 upon ns square minus 1 upon ni square. So basically here is the final state. So in our case the final state is 5. So we have to take the square of 5 minus 1 upon ni square. So ni is the initial state, that is 1 square. This r is the Rydberg constant. So basically we can calculate the value of 1 upon lambda using this equation. We are going to use this in the next steps. So once we calculated that value of the 1 upon lambda, the next thing is we have to calculate momentum of photon. So momentum of photon is given by h upon lambda, where h is the Planck's constant. Now we have already calculated the value of 1 upon lambda, right? Or here in the first step. So we will just plug in that value. So the momentum of photon will be given by h, that is Planck's constant, into whatever we calculated in the first step. Now the reason why we have calculated the momentum of photon is because since we have to calculate the recoil speed of the hydrogen atom, it acts like it is analogous to person firing the bullet. So when you fire the bullet, the gun experiences a recoil speed. So we have to see that analogy over here. So that's why we are calculating momentum of photon. So basically momentum of photon is gonna be equal to momentum of hydrogen atom. So now we have calculated the momentum of photon. In the next step, we will calculate hydrogen atom's momentum. Let us say mass of the hydrogen atom is m and the recoil speed or the velocity is v. So momentum will be given by mv, which will be equal to momentum of photon that we have calculated over here. Then mv will be equal to h into r 1 upon 5 square, because that hydrogen is coming from the energy state 5 to 1. That's why we have put 5 here, and here 1 square, which will be 1. So which comes out to be hr into 24 upon 25. You can ignore this particular sign because we have to just calculate the speed. The next thing is we are plugging in these values of the Planck's constant and Rydberg constant. Okay, these are the values. They are supposed to provide these values in the G mains exam, so you don't need to remember it. Then into 24 divided by 25, and over here we have got the mass. Okay, so hydrogen's mass is 1.67 into 10 raised to minus 27. Sometimes they don't provide these values, the mass of hydrogen, especially for the hydrogen atom. You need to remember those values. Okay, mass of the hydrogen atom is 1.67 into 10 raised to minus 27. Along with that, you also need to remember the electron's mass. But in our example, we just need the mass of hydrogen, so we have plug in that value. And finally, we have to just calculate all these things. So here 10 raised to minus 27 will cancel out with 10 raised to minus 34 and 10 raised to 7. Then what remains is 6.63 into 1.09 into 24 divided by 1.67 into 25. So there is a lot of calculations involved in this, but finally you will get this answer like that, 173.44 divided by 41.75, which comes out to be near 4.15 meters per second. And in the option they had given 4.17 meter per second, so it is approximately equal to 4.17 meter per second. That's it. So that's how you can calculate the recoil speed of the hydrogen atom when the photon is emitted. If you have more questions, let me know in the comments. Thank you for watching.